Hi, my name is Cheryl Riley. I am an adjunct instructor here at Rappahannock Community College, and today I'm just going to talk to you a little bit about the electrical conduction system of the heart. So you have been given a small little device called an EKG recorder that will pick up the electrical conduction system within your heart and show you an EKG on your screen. And an EKG is an electrical cardiogram, which is an image or a representation of the electrical conduction coming from your heart, and it demonstrates what is actually happening in your heart. The electrical conduction system is made of several components. We're going to talk about just 4 of them to keep it simple. We have the SA node, the AV node, the bundle of His, and the Purkinje fibers. Now this electrical conduction system coursing through your heart muscle is what makes your heart contract. It's what makes your heart have that lub-dub heartbeat that you have. When the SA node fires, the atrium, the upper 2 chambers of your heart, contract. After they contract, it sends the blood down into your ventricles, and then your ventricles contract, and that sends the blood out to your lungs and out to the rest of your body. With this electrical conduction system, this is what keeps your heart beating, which has been beating every day since you were about 10 weeks in your mother's stomach, without fail, every day. And what we know is that our electricity that comes out of our heart can be picked up on these electrodes placed on your chest, and it gives off enough signal that goes down those leads and those wires and shows a pattern of how well your heart is beating. So I'm going to talk to you a little more about this electrical conduction system that you have in your own heart, and how some scientists way long ago figured out that they could hook you up to the leads that you have, place them on your chest. There are different configurations. What you have is a 3 lead, so you only have 3 stickers to place on your chest. And that lead system picks up that electrical flow, and then it prints out. For us, we usually print it on paper, or we watch it on the computer when our patients are hooked up to it. We watch it on the computer. You're going to watch it go across your computer screen too. And every one of those wave formats means something. So we're going to look a little further now, and I'm going to take you to the next slide. And in our next slide, we talk about the SA node. The SA node is the fastest rate of automaticity. It lives up in your atrium. It is considered the primary pacemaker of the heart. So what we mean by that, it is the main source that all of our heartbeats start off from. And heartbeats that run 60 to 100 beats per minute are coming off of the SA node. If that SA node failed to fire for some reason, damage or a change in the electrical conduction system, then we have a backup, and that's the AV node. And the AV node will also fire as the SA node to the AV node, but sometimes it is the initiator. So the SA node is the primary pacemaker. That's where we expect most of our electrical startup to come from in our heart, the first representation that you'll see on the EKG. But sometimes if the heart rate is really slow, that's originating from the AV node. That electrical conduction system continues on down through the heart, starting up at the atrium, running through the AV node, and after the AV node we get the ventricular contraction, and that is controlled through the bundle of His and down into what we call the Purkinje fibers, way down in the base of your heart. Okay? So it starts at the SA node, travels through to the AV node, through the Purkinje fibers, through the bundle of His, and then through the Purkinje fibers. And this is the normal electrical conduction system. So as long as everything is going well, you have a nice healthy heart, and you don't have any damage to your heart, that is what your EKG electrical conduction system pathway would be. When we look at the electrical conduction system, there's much more complication to it as far as what happens within the cells. So within the cells, the individual cells within the muscle of the heart, there is depolarization and repolarization. And this is what gives off that electrical charge. Once we have that electrical charge, we can pick it up on the leads, and then it can run through the EKG and then show up as an EKG pattern. It is defined on graphic paper for the nurses to read. You're not going to see it on graphic paper in your little kit, but it does get printed out on graphic paper, and each representation, each waveform means something. Each waveform tells us what part of the heart was contracting, how long it took it to contract, how quickly the conduction system went through the heart, how fast the heart is conducting their heartbeat. And a normal heartbeat should be between 60 to 100. Anything less than 60 is considered slower or bradycardic. Anything greater than 100 is fast, tachycardic. So both of those would be considered abnormal, but for some folks, it is kind of normal. And what I mean by that is some patients will have a slower, or some people will have a slower heart rate, but that's because they have a very healthy heart. We often see a slower heart rate in athletes. Sometimes people run a little faster. Maybe you just had a soda. Maybe you just had a lot of caffeine. Maybe you drank a Red Bull. Maybe you drank a Monster. And then your heart rate would be naturally a little faster. So the electrical activity prints out on this graph paper, and we can measure it out on that graph paper and tell us how fast your heart rate is, how long it took the electrical impulse to travel from the SA node down to the AB node, and then we can tell you how long it took from the AB node through the bundle of His and through the Purkinje fibers. And over time, scientists have figured out what is normal, what is abnormal, and what that might actually mean to what's happening in the heart. Looking at this slide here, you can see a picture of the heart. You see where the SA node is represented. You can see where the AB node is pointing to in the second little bundle of yellow there. You can see that the right atrium and the left atrium are depicted here, and how these electrical conduction is affected from both sides. The SA node here runs over to the left atrium as well. It shows the AB node, and then as you go down in here, you can see the left ventricular and the right ventricular, a depiction of the bundle of His, and a depiction of the Purkinje fibers running all the way down into the bottom. So this is a nice depiction of the electrical conduction system within the heart, showing the anatomy of the heart. And then we also can see here, this is a representation of how it looks on the graph paper, with a waveform here beginning, and then one that kind of, I like to say, looks a little bit like a lightning bolt, and then another wave pattern behind that, and then another waveform again. This is an image of 2 heartbeats, is what you're looking at there. And the representation of that contraction shows and gives off that electrical impulse that can be depicted on the graph paper. So notice your first little bump is not quite as dramatic as the big lightning bolt looking thing in the middle. That first bump is when your atrium contracts, and the second lightning bolt looking bump or movement there off of the EKG paper, that is the representation of your ventricles contracting. And notice that's much grander because it takes a lot of electrical impulse to get your ventricles to contract. That's a lot of work pushing that blood out to your lungs and out to the rest of your body. And then you have a bump that lives behind, or a wave that lives behind the big electrical pattern there, if you will, or waveform. That was the ventricles, and then you have one right behind it, and that's when the heart takes a little bit of a rest, and that's when the cells repolarize or rest, and then does it all over again, and has been doing it nonstop all of your life, which I think is just so cool. Anyway, that concludes our video today on how and why you have a electrical conduction system and why you're seeing the waveform that you are seeing on your computer when you hook up your little EKG recorder. Thank you.